Okay, so there's two things about our current portal setup which just aren't going to fly when we want to say, for example, attach the portal to a tracked plane. You know, I want to place a portal here with whatever rotation and in any direction. Okay, we want to be able to do that. And the other thing we want to be able to do is say, oh, okay, so I've got my portal here, right? I've got my portal here, and let's say I want to go towards it, right? And then I'm in this other direction, right? Other dimension, and then I come back around. I want to be able to go back through it again and be back in the real world. In other words, a bidirectional portal. You know, like maybe you might imagine like Stonehenge, right? You know, you got these doorways. You'd imagine that if there was something in the middle of them, then you'd be able to get through to it on either side. You don't have to be coming from a certain direction. So these are the two things that we're going to implement in our new way of thinking about our portal behavior. So we'll jump into our see this interdimensional transport script. We're just going to duplicate that, and we're just going to rename it. Just call it portal. We'll just call it portal. And we're just going to change some of the settings of it. Now remember, if we change the name of a file, then we really got to change the class name as well. So we change the class name to portal. The first thing I'm going to do is just clean up all this behavior. Really, what we're doing when we say set materials, what we're saying is set the materials to either fully render or only render inside the portal. So we'll do a function to reflect what it actually does, right? So we'll just say void set materials, and we're going to pass in a bool, say full render. Do we want to fully render everything or not? And that's a very clean way of kind of thinking about what we're actually doing. So first of all, we can just grab our for each statement. We're going to put that inside there, and we're going to create our compare function up here. So actually, what we want to say is we say if we say var compare function. We'll do a ternary. Ternaries are always easier to read, and we won't call it compare function. We'll call it stencil test, and that's going to equal if we're in full render. In that case, then we're going to say, okay, yeah, we're rendering fully. Then we want to render everything that's not equal to the one that we've set on our stencil. So we say compare function dot not equal. Otherwise, let it equal compare function dot equal. And down here, we'll make sure that we're setting it that variable that we've created. And that's going to be a much cleaner way of working. And we can now go to our start function, and now we can say something as simple as set materials full render. No, we don't, because we want to start the game where you're not in this other dimension. So we'll go false. And in the onDestroy, we want to do the opposite, because we want to work with our assets while we're in this other dimension. So we'll go set materials true. Now with this onTrigger state stuff, we're going to rethink all of this. This other.name, that's a very dangerous way of doing it. Oh, what if the designer goes and changes the name of it? Or what if we import, say for example, ARCore's prefab for a camera is called like first person camera or something like that. So what we're going to do is we're going to be much more explicit. We'll go up to it, we'll create a few new variables. And so the first one's just going to be a public transform, and it's we'll just make a device transform. So go transform device, and also we're going to need a few variables to make sure that that we know what we're comparing against when we say what are we currently in front of the portal, and what were we last time. If we were last time behind the portal and we're currently in front of the portal, that means that we've just done a transition. So we'll just have a bool, and we'll just call that was in front. And we'll also have a bool. We also got to know what do we do once we're in that other dimension. Once we've done that transition, what do we do? Do we go back to being regular AR, or do we go into this other dimension? So how we do that is we can have another bool and say, are we currently in the other world? So we say bool in other world. Yeah, and by default both of these will be false, and that's fine. That's perfect. What we want to do is before we start doing our comparison, we want to set it up so that no matter where we start coming from coming at the portal, we want to say we're comparing like currently, you know, like so what we want to say is like as soon as we enter this collision, or this trigger rather, as soon as the trigger enters, we want to say, okay, well we'll set the was in front to whatever it is when we start our collision, start our trigger, and then as we go through that transition, we'll be able to keep updating and tell us if that changed. So how we can do that is we just go to void on trigger enter collider other, and remember we got to get rid of it if other dot transform is not equal to device, then it's some other transform we don't want to work with. So we'll just say return. Otherwise, we want to say was in front is equal to our new function we're going to create, which will return to us the camera or the device's position relative to the orientation and position of our portal. So we'll create a new function which will return to us a boolean. Is it going to be in front? So we'll say get void bool get is in front. And what that's gonna, first of all, what we're gonna need to do is we're gonna need to get a vector 3 of the relative position. So how we can do that is just say vector 3 pos equals transform dot inverse transform point. Now that's gonna do two things for us. That's gonna whenever we pass in a vector 3, it's gonna give us a vector 3 with a rotation that's relative to our portal's rotation, and also a position that's relative to our portal's position. In other words, our portal's position is the origin, right? And it's going to give us our other vector 3 compared to that origin. In this case, it's going to be the position of our device relative, to our portal's device. So we can say inverse transform point device dot position. And now we're going to say if it's in front, then if it's in front, then I want to return a true. If it's behind, I want to return false. So we just say return pos dot z is our forward vector is greater than or equal to 0, then we'll return true. Otherwise, return false. Okay, and a little question mark in there because we're using a ternary operator. And now was in front is just going to equal to get is in front. All right, beautiful. And now all we got to do is we got to when we're actually inside this trigger mode, once we've actually got that original position, what we want to do is we want to keep comparing again. Say, has it changed yet? Has it changed yet? If it hasn't changed, don't worry about it. Okay, so but before we do that, we just make sure we're talking about the same code as up here. So we just say if other dot transform rather is not equal to device, then we're talking about some other transform we don't want to work with. So go return. Otherwise, let's do this compare. So that we're gonna have to have a logical condition, right? It'll be if I was in front and now I'm behind, or I was behind and now I'm in front, right? So I can say if so first of all I got to find out whether or not we're currently in front, right? So bool is in front. Oh, oopsie daisy, excuse me. Bool is in front equals get is in front. And now we say if this is going to be inside brackets, make sure we get our order of operations right, and we say if is in front and we weren't in front before, and it's not true, and it's not true that was in front, or was in front, and it's not true that we are in front. If there's been a change, in other words. Now, if that's true, we're going to do two things, right? We're going to invert our in other world bool. So, all right. So if we weren't in the other world, then we are now. If we are now, then we're not anymore. And the other thing we're going to do is we're going to set our materials accordingly. So we'll say is in other world equals not in other world. In other words, whatever it was, to make it the opposite. And now we're also going to say set materials. And do we want to fully render? If we're in the other world, yes, we do want to fully render it. So we can say set materials in other world, and whatever that variable is, it'll set it accordingly. Now, before we exit out of this function, we just need to make sure that we set our was in front to is in front. So like for the next frame, we know what we were in the last frame. So was in front equals is in front. Is in front. Lovely. And actually, I believe that's everything we need to do for this for this portal script. So now we just need to implement it. Remember that before we have our portal window has this interdimensional transport script. We can remove that, and we can attach our portal script, and we just make sure that we set all of our materials. There's 3 of them now. There's the park material. There's our aluminum material, and there's also our skybox. Lovely. And also we want to set our device, and that should be good to test. Okay, so so we're outside of this other dimension. We go on through here, and it all changes. Okay, that seems to be working very well. Now, the way that we've set it up, it shouldn't matter which direction we're coming from. It should still be able to flip every time that we go through. And there we go. Same as before. It's hard to tell when we got this weird stuff going on. Maybe we can find a way to fix that. But now I can go through again, and it'll change back. And so we got this really nice functionality. It doesn't matter where you're coming from. It's going to work just fine. And that's pretty much everything. I suppose one more thing I want to do before we start creating like all these, like what I'm thinking is like new scenes. If we want to do like ARKit, I'd imagine if you're deploying, say you're making a game, you're going to want to make a different, like an ARKit scene, an ARCore scene, etc. With that in mind, let's create a world prefab, which will be our park and our portal, all in a nice position, and also with a sensible origin of that game object. So I'll just create a game object, call it world. I'm just going to reset it. And I'm going to drag my park and my portal inside there. And all I want to do is I want to make sure that my portal, which is currently at this sort of like a strange position, I'm going to reset my portal's position. I'm going to move it forward just a tiny bit. We'll imagine that our camera is starting at the position of 0, right? That's what we imagine. So our world is at 0, our portal is a little bit forward, and maybe if the portal's ground is going to be so for the portal at 0, we want to say the camera's going to start at, let's say for example, I don't know, 1.5 meters for a child maybe who's going to pick up the game. Then we want to say the portal is 1.5 meters down and a little bit in front. So we'll say negative 1.5, and now we'll just set our on the y-axis, and now we'll just set our park to be flush and maybe in that same position it was before, which was pretty nice. Relative to our portal's position. Now, obviously, like if we're gonna maybe in the future, what we can do is have the actually like place the portal on a tracked plane, which would be a really nice way of doing it. But for now, for testing and stuff, we just get things easy to import to a fresh new scene. Okay, so maybe we want it something like that. And yeah, so our let's see, our world position, that's our 0 on the world position. Is it? And or is that taking that might be an average actually. Yeah. And our portal, yeah. Our portal's at negative 1.5 and about 1.7 meter in front, so about 2 meters in front, and that'll be very nice for us to work with. So we can just drag that world into a prefab, into our prefabs folder, and now we can start with a fresh new scene. We've got our skybox working, we've got everything sort of hooked up, and we can start actually putting it into AR, see what that looks like.